Okay, so in this lesson, we're going to talk about the properties of logarithms. And this is going to be, the idea of logarithms is going to involve several lessons. We're going to look at properties, we're going to look at graphing logarithms, we're going to look at solving log equations. So it's a few lessons that's going to be involved here. But for this part, we want to talk about the properties of logarithms, because there are certain properties of logarithms that are used in many applications. Okay, so the first thing we want to talk about, or that I want to remind you about, is the idea of inverse functions. So let's kind of review inverse functions for right now. All right, so we'll review inverse functions. And this is just a quick review. You need to go back to the lesson, and there were a couple lessons that dealt with inverse functions. But in terms of reviewing inverse functions, basically what I want to remind you of is this. So, and this is going to be, and this is in your Canvas packet, but in particular, number 2. So if a function is 1 to 1, then the inverse can be found by interchanging the x and y in the function equation and solving for y. So you did a few of those examples previously. And then number 1 says if a function is 1 to 1, then its inverse is a function. And if a function has an inverse, then we denote it as f inverse. So remember, don't confuse that with f to the negative 1 power, because that's not an exponent. We talked about that idea in a previous lesson. So that means f inverse of x. All right, and a function has an inverse if no horizontal line intersects the graph of f at more than one point. So that's the idea of that 1 to 1. So basically, if you look at an exponential function, so if you look at any exponential function, the question I'm going to ask you is this. So notice that this is a horizontal asymptote. Here's the question. So is this exponential function a 1 to 1 function? 1 to 1 function. Okay, so that's the question. Is this exponential function a 1 to 1 function? So remember, a function, it's a function, right? So first of all, it has to be a function because we're calling it a function. So it passes the vertical line test. It is a function. For each x coordinate, there's only one y coordinate. A 1 to 1 function is the other way. For each y coordinate, there's only one x coordinate. So if you look at all these points here, let's say you look at this point right here, whatever that point may be, for that y coordinate, is there just one x coordinate? Yes. For this point right here, for that y coordinate, is there just one x coordinate attached to it? Sure. So that means that this function is 1 to 1. It passes the horizontal line test. So that's what part of number 1 was discussing, the horizontal line test. So since it passes the horizontal line test, then that function is going to have an inverse. So basically, I want you to remember this, and we're going to talk about this in another lesson, but all exponential functions have an inverse. All exponential functions are 1 to 1, or 1 to 1, or 1 to 1 functions, and therefore have an inverse. Okay? All right. So all exponential functions are 1 to 1 functions, and therefore have an inverse. Okay, so what I want to talk about now is this. An exponential function has this form. So remember when we first defined exponential function in the previous lesson, we said f of x was equal b to the x power. Okay, so an exponential function has that form. So if you look at an example we did in a previous lesson, let's say this right here. Let me try and get it real quickly. So remember we graphed fx equals 1 to the 4th to the x power. And so my exponential function looked like this. Here was the horizontal asymptote. We found domain, range, and y-intercept. Okay, so this is an exponential function. It is 1 to 1. It passes the horizontal line test, so it has an inverse. So that means we can find the inverse. Okay, so to find the inverse, first thing we do, remember, is we let f of x equal y. So we have y equal d to the x. And then at this point is where we interchange x and y. Okay, so remember we did that. We interchanged x and y. So that means that y becomes x and x becomes y. Okay? Now, before we go on any further, let's look at this example. If f of x was 3x minus 2, okay, we have this linear function. Do you remember how to find the inverse of this linear function algebraically? So again, just like we were doing here, we get y, or we replace f of x with y, so we get y equals 3x minus 2. Then I interchange the variables. Okay, so that means y becomes x and x becomes y. And then remember what we did at that point? At that point, we solve for y. So we solve for y. Okay? And so when I get y by itself, I'm going to add 2 to both sides. And so I get x plus 2 is equal to 3y. And then we divide both sides by 3, just like this. And so I get x plus 2 divided by 3 is equal to y. And remember, that is the inverse. So if f of x equals 3x minus 2, then the inverse will be this, x plus 2 divided by 3. It kind of makes sense because the inverse undoes what the function does. So if the function multiplied x by 3 and then subtracted 2, the inverse will add 2. See, I'm subtracting. The inverse will add 2, and then I'm multiplying. The opposite of multiplication is division, and then divide by 3. Okay? All right, but do you see right here, it was pretty easy to get y by itself, right? Because it was linear. Easy to get y by itself. So given this equation, when I interchange the variables, it was very easy to get y by itself. But I want you to look at this right here. How in the world am I going to get y by itself over here? How am I going to get y out of that exponent? That's a difficult situation. And so at this point, you really know no way of doing that. You have no way of how to solve for y. You have no way. Okay? It's not as easy as this one. See, it was easy to solve for y here. Right here, to get y by itself. It was easy to get y by itself, because that was just a linear equation, and you just use properties of equality for that. That you don't know. But here's what you do. Okay, so it turns out that you can get y by itself by using the idea of logarithms. So to solve for y, we're going to use logarithms. That's use, not lose. We're going to use logarithms. Okay, so listen carefully to this. So our new notation, remember, you don't know of a method to get y by itself. So the notation we're going to use now is going to be called logarithms. So I need for you to understand what I'm about to say. So when I got y by itself here, so you see this equation here and this equation here, those are equivalent equations. Okay, to solve for y, I did this, and those two equations are the same. So if I were to graph this equation, x equals 3y minus 2, and this equation, it would be the same line. That would be the same line. So those equations are equivalent. Okay? Now be careful. I'm not saying that these two are equivalent. They're not. If you graph this and graph this, those are two separate lines, two different lines. Okay? But what I'm saying is once you interchange the variables, once you interchange them and you get y by itself, then that part, that equation, and that equation are equivalent. So this equation here, remember I want to get y by itself, right? So I want to get y by itself. Here's going to be our notation. So this equation is equivalent, that equation is equivalent. So here's our notation. You just got to know that given this exponential function that looks like this, an equivalent equation would be this. Y equals log of x base b. Now here's the important thing, that when I said base, that's a subscript. Okay, that's a subscript. So you see how, if you had line paper, how y equals log x would be on the same line, and then you have a little subscript b, that's your base. Okay, so these two equations, so this exponential form here is equivalent to this log form. So the exponential form x equal b to the y is equivalent to the log form y equals log of x base b. Okay? All right, so just look at the different characteristics here. You see how the exponent here, that's what I want to solve for? So that goes here, equal, and then you're going to say log. A log always has a base. A logarithm always has a base. Now, it's not just any base, we're going to talk about that, but it has a base. That base is the same as this base. Remember that's a base and that's your exponent? So here's your exponent. You're going to say log, that base here is what you see here, and then we're going to call this the argument. The argument, and the argument is what's on this side. Okay? All right. So if you can remember, how to change exponential form to its equivalent log form, you'll be fine with what we're about to do. Okay? All right. Now, okay, so a couple of things we're going to kind of review now. So what I want you to remember is this. So the inverse, and remember I was trying to find the inverse of this, right? So the inverse of the exponential function f of x equal b to the x with base b, notice the base is b, is called the logarithmic function with base b. So if this is my function f of x and it has this base, then the inverse the inverse is a log function, okay? And it will have the same base. It will have this base. So f of x, the inverse of f of x equal b to the x is f inverse log of x base b. Okay? All right, so see once right here. So remember we replaced y with x. Okay, so we interchange the variables and then I get y by itself. Well, here's y, so that's your inverse. So this is the inverse of this. Okay, so that's what this says. Okay, all right. Now, let's look at this. So this is going to be the definition of a log function. So the definition of the logarithmic function. So for x greater than 0 and b greater than 0 and b not equal to 1, and we'll come back and we'll explain what I'm writing here. Then y equal log of x base b is equivalent to, all right, now let's look at what I'm about to say. So you're going to write, remember, a log expression you can write as an exponential. Okay, so that's what we were talking about here. So I'm going to write this log expression as an exponential. Okay. All right. So so this log form is equivalent to this exponential form. So what's my pen? So b to the y. So here's how you convert to an exponential. Your base is b. Always look at your base first. Okay, my base is b. You're going to raise it to what's on the other side. So b to the y, see right here, equals the argument, whatever you're taking the log of. All right? Okay. So let's come back over here. So this right here is equivalent to b to the y is equal to x. All right? So here's my log form. You can always change a log to an exponential, and you can change an exponential to a log. Okay? All right. Now, remember this. So this right here is your base, right? So that's your base, and that's your base here. All right, so those are the same bases. Okay, here's your exponent. All right, there's your exponent, and your exponent comes here. You see that? All right, so just remember that. So remember the pen movement. So I'm going to go ahead and write this again, and this is going to be important. So think of the pen movement. I want to change a log form to exponential. And I can go both ways. Change a log form to exponential. So to change a log form to an exponential, look at the base first. What's the base? The base is b. I need an exponent. I need an exponent of the base. So the base is going to be raised to that power, and that's going to equal the argument. Okay? So you got to look at that pen. All right. Now let's look at some examples. And, oh, by the way, I forgot to mention this. So remember when we talked about exponential functions in a previous lesson? We said that the base, when you're looking at an exponential function, if you go back to the previous lesson, all the bases were positive numbers. Remember, you could also, your base cannot equal 1. Remember that? We saw the reason why it could not equal 1, and it cannot be 0. So hence, it has to be positive, greater than 0. It cannot equal 1. And your exponent, we defined it. Your exponent was, in this case, your exponent, we're going to let x be greater than 0. And there's a reason why we want x to be bigger than 0. Here, when we did in the previous lesson, x could be any number. Okay, so you saw that. You saw where we had exponents that were negative. But there's a reason, and you're going to see this soon. There's a reason why this time, this argument has to be strictly positive. Okay, so you're going to see that in a little while. All right, so let's look at some examples. Okay, so the first thing you want to do is to be able to change. You want to be able to change from logarithmic to exponential form. Okay, so you want to be able to change from logarithmic to exponential form. All right, so for example, number 1, suppose I have 3 equals the log of x base 7. So that's how you read this. 3 equals the log of x base 7. You can also read it as 3 equals the log base 7 of x. So I'm going to write out how to read it. So it's read as 3 equals the log of x base 7, or you can say 3 equals the log base 7 of x. Okay, either one. All right, so that's how you read this. But ask yourself, what kind of form is this in? Is this in logarithm or exponential form? Obviously, it's log because you see the word log, right? Okay, so remember the pen movement. How do I change log to exponential? So first of all, we write the base first. Look at the base first. So the base here is what? It is 7. So the answer, you're going to say first 7, and you always have to have a power. What's the power? The third. So 7 to the third equal x. So there's your answer. And remember, you can always transpose sides of an equation. So you could have said x equals 7 to the third. Doesn't matter. Right equals left, left equals right. Okay? All right, number 2. So it's very simple. These are very simple to deal with. All right, suppose I had 7 equals log of 22 base b. Okay? 7 equals the log of 22 base b. And guys, notice how if this were lined paper, see how 7 equals log 22 is on that same line? And then the base is written more as a subscript. Okay, make sure it looks like this. Okay, make sure it looks like this. All right, so what kind of form is this in? This is in log form. I want to convert it to what form? Exponential. So let's talk about the answer. First thing I would do is look for what first? Look for the base. What is it? It is b. You write it. Then I look for the exponent. What's the exponent? It is 7. And then that's going to equal the argument. What am I taking the log of? I'm taking the log of 22. And there's your answer. So b to the 7th equals 22. And that's all they wanted you to do. Okay, there's no solving for x, no solving for whatever. That's it. That's exponential form. That's exponential form. You're done. That's all they wanted you to do. Okay? All right, number 3. Suppose you had log base 2 of 9 equals, let's say, y. Log base 2 of 9 equals y. So what's the answer? How do I change this log form to exponential? Well, what do you look at first? You look at the base. What's the base? 2. 2 raised to what power? 2 to the y. And that always equals the argument. So what am I taking the log of? I'm taking the log of 9. All right? Okay. Now, let's look at another kind of example. Now we're going to go backwards. Example. So this time we're going to change. We're going to go from exponential. So change from exponential form to log form. All right, so change from exponential form to log form. All right, so here's an example. So this is number 1 for that one. Let's suppose we had 8 to the 5th power equals, let's say, x. All right, so I want to change this to log form. Okay. All right. So in other words, I want to go from here to here. So what I would do is I'd have an equal sign. That's the first thing I would do. Put the equal sign. Then write the word log. Okay? Because remember, when you go from exponential to log form, you have the word log, right? Okay. All right, so that's the first thing I would do. Then we got to find out what the base is. So what's the base over here? Is the base 8, 5, or x? It's 8. So write this as a subscript, just like this. Okay? All right, now think about what we just did here. So this says 8, and remember when I change a log to exponential, I said 8 to the power, right? That was your power. That was your exponent. What's the exponent here? 5. So that goes here. And then the argument is whatever's left. So what's the argument here? X. And always check yourself. Check to see if you get this back. 8 to the y equals what? X. 8 to the y equals x, and that's what that is. All right? number 2. Suppose in number 2 I had, let's say, b to the 5th equals, let's say, 7. b to the 5th equals 7. So you want to go from this exponential to log form. So remember, the first thing you do is say equals log. All right? Because remember, to go from log form, you're going to have this expression, right? Okay. Now, the next thing you do is write the base. So which of these are your base? Is the base? B. So you write B as a subscript, just like this. Now think, b to what power? B to an exponent, b to the exponent. What's my exponent here? 5. So 5 goes here. And then what is left that you see? 7. So 7 is your argument. So b to the y equals 7. That's what you see here. Okay. Number 3. Suppose in number 3 we had this. We had e to the, let's say, y power equals 10. E to the y power equals 10, let's say. All right? So, you want to change that to log form. So you're going to say equal log. All right, what's the base here? Base is e. So we're going to put e as a subscript, rather. So think e to what power? So what's my power? Y. So y goes here. And then what's the argument? The argument is 10. Now, in a little while, you're going to see another way of writing this right here in a little while. All right, but for right now, just leave it as e, base e. Okay? All right, now, the next example we want to look at is this. All right, so in the next example, we're going to go ahead and evaluate logarithms without a calculator. All right, so example, evaluate each of the following without using a calculator. All right, so evaluate each of the following without using a calculator. Okay, number 1. And so we're going to come back and we're going to use everything we just learned a while ago. So that's going to help us. Okay, so let's go to number 1. Number 1, let's suppose I had this. Let's suppose I had log of 64 base 4. Log of 64 base 4. Okay? Now here's the way I would do this. So I want to find out, remember what you want to do is find out, that's what you're interested in, is find out what this is equal to. So what goes here? All right, what I would do is this. I would change this to exponential. All right, so let's go ahead and change to exponential. So you see how I want to find out what that is, right? So I'm going to put this as a box for right now. Okay? And so this becomes 4 to box. So this will be our solution or our work. 4 to box equals what? 64. So 4, and now this you can do by yourself in your head. 4 to what power 64? Well, let's think. Is 4 squared 64? Nope, because 4 times 4 is what? 16. Is 4 to the third 64? I don't know. Let's check. 4 times 4 times 4. 4 times 4 is 16. And then what's 16 times 4? Let's see. 4 times 6 is 24 and 64. So there it is, right? So 4 to the third goes here. So that's 4 to the third. And so what's the answer? 3. Okay? So the log of 64 base 4 is equal to 3 because 4 to the third equals what? 64. Okay, so the answer is 3. So in the blank, however it looks, on my math lab, whatever it says, whatever the blank is, you're going to put 3 in the blank. All right, number 2. Okay, number 2, let's think about this. Let's suppose we had log base 14, I'm sorry, log of 14 base 14. Log of 14 base 14. All right, well, if I use that same idea, I'm going to go off to the side and do it here. So basically, I want to know the log of 14 base 14 equals, I'm going to put this as box. So I got to figure out what that is. So remember, the thing you want to do is change this to, so change to exponential. Well, if I'm going to change that exponential, I got to have an equal sign. So let's use this as our unknown right here. So you're going to say 14 to the box equals 14. Well, 14 to what power is 14? The first, right? 14 to the first is 14. So our answer is 1. So the log of 14 base 14 equals what? 1. Okay, number 3. All right, suppose number 3, and you got to remember something from what we talked about at the beginning of the semester and from previous courses, what I'm about to do. Okay, now, what if you had this? The log of 4 base 16. Log of 4 base 16. All right, now before we do that one, let's look at number 4. I'm put number 4 right here. Suppose I had the log of 16 base 4. And at this point, you can do this without any work because you now know what to do. So if you want to find out what this is, right? So 4 to what power is 16? 4 to what power is 16? What's the answer? 2. That's the answer. But here's what we have here, though. Let's think about this. So I'm going to put equal blank. So we're going to say 16 to what power? 16 to what power equals 4? That's a little bit more difficult, isn't it? That's more difficult to deal with. Well, let's think about this. You have dealt in a previous course with rational exponents. And I want you to... So you kind of ask 16 to what power is 4? That's basically what you're asking. Here you're saying 4 to what power is 16? So 16 to what power is 4? So so basically you're asking 16 question mark equals 4. Okay? And so we're going to change this to exponential. And so I want you to think about this. 16 to the 1/2, which is the square root of 16, right, is equal to 4. So 16 to the 1/2, remember when you have those rational exponents, you can change that to a radical. So 16 to the 1/2 means the square root of 16, and that's equal to 4. So 16 to the 1/2 is equal to 4. Okay, number 4. Suppose we had this number 4. Suppose we had the log of the 5th root of 2, that's 5th root of 2, base 2. Okay, so the log of the 5th root of 2, base 2. And so remember, you want to find out what that equal to. All right, so if you change that to the exponential, you would say 2 to what power is equal to the 5th root of 2. Now, what I would do here is I would change this to a rational exponent. So change the radical to a rational exponent. And you learned that in the previous course. And so you'd say 2 to what power is 2. And the 5th root of 2 means the same thing as 2 to the 1/5. Okay? And so notice the bases are the same. So since the bases are the same, then that means these exponents have to be equal. So that means that this box here has to equal 1/5. So 2 to the 1/5 is equal to the 5th root of 2. So that's 1/5. So the log of the 5th root of 2, base 2, is 1/5. All right, what about this, number 5? Suppose we had the log of the 7th root of 3, base 3. Same thing like this one. So you're going to say log of the 7th root of 3, base 3. You're going to put You're going to see what that's equal to. So change that to exponential. So you're, in your mind, you're saying 3 to what power equals the 7th root of 3. Now rewrite this radical as an as a rational exponent. So the 7th root of 3 is 3 to the 1/7. And so notice you have 3 to the box. 3 to what power is 3 to 1/7. Well, since the bases are the same, then the exponents have to equal. So that means that this exponent has to equal 1/7. So this right here is equal to 1/7. Okay, number 6. Suppose you had log of 6 base 36. Log of 6 base 36. All right, same idea. You're going to say log of 6 base 36 equal box. So 36 to what power is 6? All right, so think about this. If I take the square root of 36, does that give me 6? It sure does. So the square root of 36 is 6, right? Well, square root of 36 means the same thing as 36 to the 1/2. Those two are the same, so this is 1/2. Okay? All right, so that's 1/2. And then finally, number 7, suppose we had log of 1 over 125 base 5. Log of 1 over 25 base 5. All right, now the way I would do this is this. Now this is much more difficult to deal with, but here's how I would deal with this. I would rewrite 1 over 125. So remember, 1 over 125 means the same thing as 1 over 5 cubed. Okay? See, this base is 5, so I'm going to rewrite this with base 5. Well, 5 cubed is 5 times 5 times 5, which is 125. But 1 over 5 cubed means the same thing as 5 to the -3rd. Those two are the same thing. All right, so I get this. I get log of 1 over 125 base 5 equals box. And so 5 to the box equals, and remember 1 over 125 is this, so that's 5 to the -3rd. And so if the bases are the same, that means that these have to be the same. So box has to equal -3. So the answer is -3. All right, so this one was much more difficult. You have to remember some things from a previous course to do that. All right, so that's going to take care of part 1. So in part 2, we're going to continue on with this with some other ideas.